I just explained it today in one of my classes. Just a second. Picking up the continuity correction. Okay, these are the rules for the continuity correction. Let's suppose, for example, in the first case, which is over here, they are talking about x is greater than 65. It means 65 is not included. So
Yeah.
do you know what will you do? Like 65 is not included when you are converting that thing into the normal condition. So at that time, you will be going in that way. You will
Yeah.
be standing exactly at that point, which is 65.5, because they're not willing to add 65 inside that one. Na? So at that time, you are just going to start with 65.5. Okay. And then when they were writing it, probability for x greater than equal to 65, it means 65 is included, isn't it?
Yeah.
So when 65 is included now, so it's a responsibility that we will not stand over here, we will stand over here and we'll go on the right hand side. So it means now we will be counting from this part
Mm-hmm.
because 65 should be included. So we can say that it will be 64.5.
Okay.
Okay. And when they were telling you less than 65, so what does it mean? If they are telling you less than 65, so it means that 65 is not going to include, because you have to go on the left hand side, so you will keep on standing over here and you will go in that way. So it will be 64.5. You can see it over here.
Yeah.
Okay. Now when they were telling you less than equal to 65, less than equal to 65, it means that 65 should be included. So you have to stand at this point and you will go on the left hand side. So it means you will be starting with 65.5. Okay.
Wait,
Eh,
less than 65 means what again?
less than 65 means like 65 should not be included. So you will be standing over here and going in that way. So it will lead you 64.5.
Okay.
Okay. But when they are saying you less than equal to 65.5, it means that 65 should be included. So you will stand at this point and go on the left. So it means 65.5 will be considered.
Yeah.
Okay. And furthermore, like if they are telling you x equal to 65, so it means 65 cannot be calculated, because the thing is we cannot calculate that attempt in the normal when we are dealing with the approximation. So what we will
Mm.
do, 65 is not exactly calculated, so it means we are going with this one and this one, like 64.5 and 65.5. This is exactly the continuity correction. It is just like that. Whenever the term is rounded to the nearest integer, na, we will go for 0.5. When the term is rounded to 0.5, just like that 63.5, so it means it is rounded to 0.1, isn't it?
Yeah.
So 0.1 divided by 2 becomes 0.05. So at that time, the continuity correction will be 63.55. It's like just like the O levels limit and accuracy. Do you remember that?
Yeah, but the part I don't understand is 5.
5. This one.
Yeah.
Okay, I'm just explaining you. This is rounded to 0.1, isn't
Mm-hmm.
it? So when you divide it by 2, it becomes 0.05. Okay. So if they are just making you write this, for example, over here. Okay. So 63.5, they are exactly standing at this point and they do not want to include that one. So you means you will go just forward for a minute and go to the right. Okay. So at that time, this is the starting point will be. So how can we go to the starting point? Like we will add, that was 63.5 na. So if I add 0.05, I will be getting the value after it. And when I subtract 0.05, so at that time I will be at the minimum value, just like this, 63.25. Got it?
So if it was probability of x is less than 63.5,
Hmm.
what would it become?
Less than 63.5, so you will start with 63.25.
63.45?
No, 25 no.
Why?
63.5. Yeah, 63.5. I wrote it wrong. 63 point, yeah, 45. It is 45.
Okay.
Okay, fine.
Yeah.
Okay, now I'm writing a question over here. 5% or more. Can you read the question?
What does it say on a morning when? What's the word after when?
When 500 pies are delivered, 5% or more are broken. They are exactly leading that 500 are delivered, so it means it is going to be the size of sample ns, and the probability means it's a proportion, 5% or more are broken. So we have to calculate the probability of proportion with greater than 5%. Okay,
No.
and furthermore, we can say that our proportion sample is directly follows the normal distribution with PS and PSQS over NS. Do you remember that? Mean, it's a mean, it's a variance, and according to the condition what we are having, PS, it is known that the 3% of the frozen pies delivered at a canteen are broken. So it means your PS is this one. PS is exactly 0.03, and when you are dealing with QS, so it must be 1 minus this one, no? 1 minus 0.03, which is exactly 0.97. Is that clear?
Yeah.
Furthermore, like when we are interested to write the distribution, so it's going to be 0.03, and 0.03 multiplied by 0.97, and the sample size is exactly 500. So PS follows the normal distribution. So can you solve it?
Yeah. So why is the mean 0.03?
Why is the mean 0.03? Why is the mean 0.03? They have given you, no? Because according to the property I have told you that the sample size, like the distribution probability proportion, distribution proportion, when they were given, so at that time it is exactly the mean. Mean is exactly the proportion.
So 3% is the proportion in this question?
Yeah, exactly.
Well, why does it not say that? Will it not say that in the question?
They have shown it is known that the 3% of the frozen pies delivered to a canteen are broken. So it is understood every time the 3% are broken. But find the probability on a morning when 500 pies are delivered, 5% or more are broken. So they are going to check the probability on 5% or more. But when you see the 3%, so it means that they actually the average is 3%.
Okay. The variance is 0.0000582.
Variance is 0.0040.
4 zeros.
0.0000
One more.
mhm,
582.
582. Okay, so I will go with the continuity correction for this one. And remember one thing. Oh, here I did not complete that line. When we need to adjust the continuity correction, it will be plus minus 1 upon 2, 0.05 for proportion. When we are dealing with the proportion, so at that time we always go with it. NS. This is the continuity correction for proportion. Okay.
What does that say?
1 upon 2 NS means 2 sample size, 2 into sample size.
Okay.
Because it's, when we are dealing with the proportion, so continuity correction for the proportion is always plus minus 1 upon 2n. So now we have that term which is P, and PS is greater than 0.05. No? Okay. So according to the continuity correction, when I'm talking about a continuity correction right now,
You're gonna do 0.05 minus 0.03.
it's a proportion beta. Continuity correction for this one is 2ns. I told you, no? Just what is it? 0.1
1 over 1,000.
over 1000. It means 0.001.
Yeah.
So we are going further, no?
Greater
So
than that, so it'll be 0.05 minus,
0.01, 0.001.
yeah, which is 0.049.
That's correct.
And then we find the Z value,
Yes.
49.
4, 9.
And
First, we
Z
will
will
convert that
be,
one. No? First, we will convert that one. It's not exactly Z. We'll convert that one by the mean and the variance.
wait, why? Yeah, I'm saying Z will equal 0.049 minus 0.03.
PS divided by under root of PS, QS, and NS, and greater than equal to 0.049 minus 0.03,
Wait, what?
and
What's the left side?
I said exactly. I wrote the formula, no? The PS minus PS, like the
This
Z,
is
no?
the this is the
Mean,
formula of Z.
yeah, exactly the formula of Z, mean and the variance. Oh, sorry, mean and standard deviation.
Okay. But we already calculated this.
Yeah, I know that. Just put it into the calculator. Maybe it is making changes. This one.
The top is 0.019.
Directly
Can
tell me the
you
whole
scroll
thing.
a bit up? It's 326. I'm telling you the answer.
A second. But give me a second.
Okay.
Okay, what is the answer? You got 0.049 minus 0.03 divided by under root of 0.03 multiplied by 0.97. Can you hear me?
It's 326.46.
No, not at all. I'm getting 2.491.
What?
Yes, I
Okay.
put I put all the stuff inside the calculator directly.
Oh, I didn't root the 0.0 something.
This is not good now.
Yeah. Do I find this on the table?
Yes, this one 2.49. You have to go for the right hand side, so it means you need to subtract that one from that one.
Yeah.
Let me do according to the condition.
It's 0.9936.
What is exactly the value of 2.491?
0.99936.
0.9936. So 1 minus 0.9936. It's a 491. Have you seen the
What?
mean difference? Have you seen the mean difference as well? 2.4 at 9 and mean difference 1.
What does that mean?
What does that mean? It
Like I did it
means
from the table.
directly the complete value we cannot figure out from the table. 2.491. So it's 2.49 is over here and mean difference 1 is 0. Okay, that was 0 exactly. Don't you know about this columns? Why do we use this columns?
Yeah, you add them, I know that. But I didn't know it was called mean difference.
It's called a mean difference. So it will be 0.0064. Okay.
Yeah.
Mm-hmm. Exam mode find after A level student. Is the paper is going to be conducted in your country?
Yeah.
Are you sure?
Yeah.
Okay. Now furthermore that we are going to deal with the estimation problems. Now first we are going to discuss about the notations. When we are dealing with the notations, Mean and variance. The true population mean is mu, and the sample will be x bar, and the unbiased estimate of the population will always be mu cap. Okay, so this is a very important notation that you should remember. You know about this one. True mean of the population.
I know
It
about the
means
first two. I didn't know about the unbiased one.
you didn't know about the unbiased one.
No, I didn't.
It will be used. So this is sigma square. This is s square, and this is sigma square cap. Have you wrote?
Yeah, one second. I wrote it.
You wrote it? Okay, now I'm just going to write the unbiased estimate formulas. Okay, and they are very important. They will not be, I guess, it will not be given that one.
You cut off.
Proportion of success, and the symbol for that one will be p cap, and the formula for p cap, you know that we have discussed this. P cap will be equal to proportion of sample, which will be equal to x over ns. Okay,
Yeah.
and it will be dealing in binomial. The population mean will be mu, which is exactly equal to x bar, and that is sigma x over ns. Ns means the size of the sample. And when we are dealing with the variance, so it will be sigma square cap, and we are having a formula of the sigma square cap, which is ns over ns minus 1 sigma x square over ns and minus x bar. And the formula for the x bar is exactly this one, sigma x over ns. Okay,
Yeah.
I guess this is the first time that you are writing too much formula. Hmm?
Yeah.
Your teacher did not told you anything. You did not
Literally,
made the notes.
we don't make notes.
Really?
Yeah.
So how do you attempt the questions?
By whatever he's told us.
It will be they both the formula are same, but it depends upon the information what they are provided in the question, what they are providing in the question. Okay.
Yeah.
Okay. So first thing is this, like that was the notations, and this formula which I use exactly, it is for the point estimation. No? Is that clear? These formulas will be leading you to for the point estimation.
Yeah, but after this lesson, can you send me this PDF as well?
Yes, exactly. I will send it to you. And furthermore, there are two type of estimations when we are dealing with the estimations. No? So there are two type of estimations. The first one is exactly this one. Like this is the point estimation, which is I have wrote all the formulas related to the point estimation. The second one is the confidence interval.
Oh, I know that formula.
Really?
Yeah, I remember I told you it last lesson.
Let's see. When I am writing the formula, just compare that one. The second one is a confidence interval. Confidence interval means like let's suppose they were telling you that mean is exactly 95%. So what does it mean? It means there are two limits of A and B which they are leading you to that condition. Now. So for example, when I'm dealing with the normal distribution, confidence interval most of the times used in the normal distribution, okay? And this means like over here this is A and over here this is B, and we are dealing with this one. This portion is exactly your 95% of the probabilities. Okay, this is it means that your mean lie in between them. Okay, this is 95%, and for this portion that must be 95% means like 5% are remaining, so there will be 2.5%, and this portion will be 2.5% of that one. Okay,
Yeah.
whenever you are having a question of the confidence interval, first of all you need to make the checklist of the given information. You always do that one. Like first thing is name and type of distribution should be given. Okay, you will extract this from the question.
Yeah.
And the second thing is variance. Variance of that population is known or unknown. And the third thing is sample size. Okay, whether it is a large or a small sample size. Okay,
Yeah.
so when you are dealing with this one, no? So after that, first you need to make the checklist. and then this checklist is leading you towards some of the important things which I'm gonna write. I need a full page. For this one, there are four cases. Case number 1, case number 2, and case number 3, and case number 4. Okay,
Yeah.
so we will start from this. Like for example, our distribution is normal distribution. Okay, and the variance sigma square is known, and sample size is any size. Okay, means it can be large, it can be small, anything. So at that time, what will happen? In this case, central limit theorem not applied, TLT not applied, and X follows a normal distribution with mean and sigma square in the variance. And in CLT, we have discussed about that when we are not applying the CLT. So we have discussed that it is exactly normal, perfectly normal, like mu for the sample I'm talking about, sigma square over n. Okay, and it is known as perfectly normal. Okay, and in this way, the formula of this one is exactly D will be equal to x bar minus mu divided by sigma upon under root of n. Okay,
What's central limit theorem again?
central limit theorem again. Again, it's over here. X is not normally distributed, so CLT theorem. Do you remember the central limit theorem? This one, Poisson distribution, or it can be the binomial
Oh, when
distribution.
you make it normal?
Yeah, when we make it normal, X bar is normally distributed.
Yeah, I understand.
And at that time, we can say that it is a perfectly, not a perfectly, we can say that approximately. I'm going in the next part now, telling you about this thing. Okay, boss. And at that time, the class interval will be x bar plus minus d sigma over under root of n. Okay, it is exactly this same formula. I just make this mu a subject. Okay,
Right. Yeah. To get which section? Like you rearrange it
Yeah, I rearrange it
to do
for the
what?
class and for making this mu a subject. This mean, na, population mean or estimated mean. And they also ask about the width of the class interval. Na. So that will be always equal to 2 c sigma over under root of n.
But what happened to the mu there?
Sorry,
What about the mu?
mu will not be used, na, in this case. Like they are asking about the width exactly over here. So the mu will not be included. We can directly calculate the width by this formula.
Okay.
And when the distribution is not normal, so at that time sigma squared is known and ns is greater than equal to 30, which will be considered as large. So at that time we can say that CLT applied means the central limit theorem is applied, and we will convert all the things from approximately, because the distribution will be approximately normal, na, at that time. We will say it is approximately normal. Okay, and we will be using the same formula. And confidence interval will be the same. And the width also be same. And when we are having the normal distribution, the distribution is normal and sigma square is not known, and at that time we say that n is greater than equal to 30, which is considered as large. And remember this thing, like when the distribution is normal, na, so it has to be remembered that CLT not applied. Okay,
Yeah. You know, in these ones, what's above root n?
what above root n?
In the fraction, what's above root n?
Sigma is this sigma, this one. Okay,
Yeah.
perfectly normal. And the formula now at that time, where when sigma is not known, na, so we will always use the estimated values, unbiased estimates, na. So when I'm dealing with this z will be x bar minus mu cap, and the cap is over here as well, because it is understood that sigma square is not known. I mean the variance is not known. So variance is not known. We are going to use the estimated value for the variance. Okay, is that clear?
Yeah.
And the class interval will remain same for this case as well, but at that time I can say I have to use the estimated of variance. Hmm. And the last one is not normal, and sigma square is not known, and n will be greater than equal to 30, which is exactly large. And at that time, because it is not normal, so we can use the CLT over here. CLT applied. And as usual, sigma is not known, so we will use the estimated value for that sigma. Okay, have you noted down?
Yeah, I'm writing the last column.
Sorry.
I'm writing the last column.
Okay.
Okay, I'm done.
Then this is the last thing which I'm writing. Okay.
Okay.
Confidence interval for sample proportion. So it will be P cap, which is equal to PS, and you know about that, X over N of S for N greater than equal to 30. So PS follows a normal distribution with PS, PSQS over NS, and confidence interval of PS plus minus the under root of PSQS over NS. Okay, by this way we can calculate the confidence interval of the sample proportion. Uh, I'm too tired today.
The S is all the S's stand for sample.
Sorry, beta.
Everywhere that it's written S stands for sample.
Yes, but when we're dealing with the proportion, na, so yeah, they all are exactly the sample. They are all exactly the sample. NS exactly. But I did not mention that one. No, I just wrote N. But over here I was just mentioning all of the things, so that's why I mentioned it. And what about the width? If width is known to 2G PSQS over NS. Okay.
Yeah.
And the continuity correction for this one is
For which one?
for this sample proportion. We have discussed that one. No?
For N is greater than 30?
Yeah.
29.5.
No. This formula for the continuity correction, that will be plus minus 1
N
upon.
and then sample size. Yeah.
Yeah, exactly. If finding probability. Can we keep till here for today?
Yeah.
I will get late now. Okay. Actually, I have to go for the bus. Otherwise, I will miss. Okay. So we have done till over here, and right now, do we have the class on tomorrow, or you need a one more extra class, now? Because one class is missing exactly. So
Yeah.
if I am available on Friday, Saturday, or Sunday, so I will update you, and you tell me your availability, so we can manage.
Okay.
Okay. Then see you. Take care. Allah Hafiz.